A very good morning, dear students. Hope so you all are fine and taking due care of yourself and enjoying these digital classes. So today in this digital classes, chemistry plus 2 class, the unit solid state we are doing. Today especially, dear students, I brought this video regarding revision of all the topics done in this week. It means that we will discuss about all the topics that we have already done in this particular week. So the purpose behind to make this video is just to recall and revise all the topics in one video, whatever we did, so that if any student, those who left or skip some topics, so they can get a chance to recover those topics. Okay, so the topic is revision of all topics done in this week. So particularly, let us revise with the this mind map of chapter. So the chapter name is the solid state. As we know that basically there are 3 states of matter: solid, liquid and gas. So in general we will do particularly the solid state. Okay, so let's discuss the solid state. So a state, the solid state is a state of matter having definite shape and definite volume. Okay, so in this particular chapter we did first the types of solid. There are 2 types of solid: crystalline solid and amorphous solid. Crystalline solid is true solids, have long range order of constituent particles and anisotropic nature. Anisotropic nature, you know very well what is anisotropic nature. And it is further classified into ionic, covalent, hydrogen bonded solids. Okay, and one is molecular, so further divided into 4. One is molecular also, so we will write it here, molecular also. Clear? Ionic, covalent, hydrogen bonded, molecular and metallic. Next is amorphous solid, that is false or pseudo solid and are also called supercooled liquid, which has short range order, mean the regular pattern is not for long range. Okay, it can be of 1 or 2, then after that it will be disordered, of constituent particle and isotropic in nature. Clear? It has different properties with the different range of, that is called isotropic. Okay, then after that, when structure of solid we were discussing about, after classification when we started structure of solid, so how the solid crystal will form, how it is, what is the framework of solid. It is the regular arrangement, that particular arrangement in which a regular geometry is there, that is called crystal lattice. It is the complete 3-dimensional arrangement of constituent particle. Complete 3-dimensional arrangement of constituent particle, as I have made in this video. You can see in this picture, this is a shape or a cubic shape of a crystal. If suppose these small units are keep on repeating and framing a 3-dimension, you know very well, in which length, breadth and we are talking about height, then it is called 3-dimensional. Okay, so whenever 3-dimensional regular arrangement is there, that is called crystal lattice, and the crystal lattice is made up of basic unit, that is called unit cell. Each unit is called unit cell. It is the smallest portion of crystal lattice which on repeating gives entire lattice. Okay, so then these unit cell are divided into 2 basic. One is primitive unit cell, second is centered unit cell. Okay, this is primitive unit cell, then second centered unit cell. We can understand with the help of these videos here, this diagram here. So crystal lattice is made up of small unit cell. Unit cell is divided into 2 parts. One is simple, one is centered. And simple cubic cell is the in which there is no atom anywhere other than in the corner only. Okay, there are atom in the corner only, rest there is no atom. That is called simple cubic cell. And centered unit cell is where other than corner there is, in addition with corner there is some other atoms also. Suppose in body centered cubic there is 1 atom in the center and 8 atom in the corner, whereas face centered there is on 6 faces. Generally there are 6 faces: 1, 2, 3, 4 down, 5 up and 6 this side. Okay, 1, 2, behind 3, this side 4, below 5 and front 6. So there are 6 faces. So it means that face center cell is those atoms, those unit cell in which 8 atoms are there in corner and 6 atoms are there in face centered. Okay, third is end centered. End centered is 8 atoms are in corner and any of 2 alternate end. Suppose this side is there, it can be this side also, it can be front this side also. Okay, front and back, it can be left and right, it can be up and down. So other of any of 2 opposite side. Okay, that is called end centered. cubic cell. So how to calculate that we did. So it is very simple. Body centered cubic cell. Simple cubic unit cell has to only simple cubic unit cell have 8 atom in a corner, divided 1/8. 1/8. What is the meaning of 1/8? So see, this is a one unit cell. Suppose this is one atom in the corner, in one edge of the corner. Like this way, it will be in the all 8 side. 1, 2, 3, 4, 5, 6, 7, 8. So if 1/8 we are talking, it means that this particular unit cell in this corner is sharing 1/8 part of this atom. Okay, so similar way, this will share with this unit cell, this will share with this unit cell, this will share with the front unit cell, this will share with the right side. Like this way, 8 cubic corner is attached with the common atom. So that's why 8th part, you know very well in math the fraction 1/8. 1/8 mean one chapati is divided into 8 person. So it means that 1/8, one person is getting 1/8 part of that chapati. Okay, it is similar way, one unit cell is getting, one corner of unit cell is getting 1/8 part of the atom. So we will divide 1/8 into 8 corner. So it become again 1/8, 1/8, 1/8, 1/8, 1/8. So 8 times 1/8 is there. It become complete one atom. Similar way, one complete atom is there in the center, which is not sharing by anything. It is in the center of the atom in the cube. So this is total one centered, one corner. So it becomes total 2 atoms are found in BCC. FCC, there are 6 faces, but each face is sharing both side. Okay, both side mean if this is the face, so half of the atom will be outside, half of the atom will be inside of this face. So it means that half it is sharing half. Each face is sharing half atom. Okay, so this 6 into 1/2, we will cut it, it will come 3. Corner same, 8, 1, so 3 plus 1, 4. 4 atoms are there in FCC. Similar way, end centered, so 2 face we are taking any of the 2 which is sharing half like a face. 1 into 1 plus 1, 2. So these are the see. So after this we have done in this particular chapter, that is we have done the structure of solids and packing in structure of solid packing. Okay, in that packing we have done close packing of solid. Mean now these atoms, which atoms is filled inside the cube or the crystal, how much close they are packing, that we are going to study. So it can be it is in 1 dimension, 2 dimension, 3 dimensions. So in 1 dimension, you know very well, in 1 dimension is single row in which coordination number is 2. It means that this center atom is touch with neighboring any 2 atom. So 2 dimension is giving us square close packing and HCP. That is arrangement 2 type. One is column and row, second is 1 row in between 2. It means that this is AA type, this is AB type. Okay, so AA type have square close packing. You can see if I will make one more line, so this is giving us square shape. Okay, square arrangement. And whereas this we are taking this, so if we are taking, I am taking this is center, so this is 1 2 3 4 5 6, so it is giving hexagonal and square. So 2 dimension have 2 type of packing, square close packing and hexagonal close packing. 3 dimension have hexagonal close packing and cubic close packing. Okay, so now when we are talking about packing, so it means that packing is the amount of atoms filled inside the particular crystal, that is packing. And how to calculate the density of unit cell. Density is same, it is how much denser is the more the packing, more will be denser, more closing the packing, more will be the denser. So there is one formula to calculate that. This we will do from Monday. Okay, so now this is the about packing. So we will understand the same packing with the help of this. So as I told you, the crystal is filled with the atom, and it is the crystal lattice which is repeating unit of unit cell. So it means that if in different type of unit cell this much number of atoms are there, it means that in complete crystal lattice there are so many number of atoms. Okay, so that is called packing. If the packing we will define, so it will be space occupied by atom in a crystal. Space occupied by atom in a crystal. So there can be simple cubic cell, body center cubic cell, FCC can be written HCP also. So as simple cubic cell have 52.4% packing, BCC have 68% packing efficiency, FCC have 74% packing efficiency. Okay, so one word we have discussed here, void. Void is what? Void is the left space between the crystal. Now the crystal shape is cube, but the sphere atom shape is sphere. So it means that when you will fill in a cube atom sphere, so there can be some space in between the atoms. So that space is called void, and this left space can be how can be calculated? Very simple, 100 minus packing efficiency. Once you know how to calculate packing efficiency, so this just do the 100 minus packing efficiency. For example, SCC, simple cubic cell void percentage is 100 minus 52.4%, it will become 47.6%. that is the void percentage of simple cubic cell. This is the packing percentage of simple cubic cell. Okay, in this way we can calculate. So hope so you understood this. And after this, now what are the upcoming topics? This was up to this we have done. Now upcoming topic is we will discuss about the defects. First we will do the density related numericals. Then we will do defects of properties of solid. Defects mean sometime all the crystals are not perfect, it is having some defect. The reason why defect is there, the types of defects. There is stoichiometric Schottky defect, Frenkel defect, Schottky defect and Frenkel defect. Okay, so the similar way non-stoichiometric defect, metal excess defect, and we will do about the conductors also. So there is a couple of classes left in this chapter. Hope so whatever we did up to now, it is clear to you. Dear students, make it sure you need to be do very much with full of consciousness, because we have some challenges in front of us. By taking these challenges, we need to do our study successfully. Okay, so hope so you enjoyed this video. That's it for today. So till then, stay home, stay safe, take care of yourself, and keep enjoying digital classes. Thank you. Have a nice day.